Hello, everybody. Developer interview number 16, and it's my pleasure to welcome Veer. Veer, you're based in Atlanta, and I haven't asked you how to pronounce your last name, so this is probably your first part of the introduction. Who are you, and what are you working on?
Actually, even my first name is a pretty long name compared to what you know. My full name is Veerabhadrappa, not just Veer. But
Okay.
for everyone's convenience, yeah, you can call me Veer. My last name is Muchandi. What was the other question you asked?
You're working at Red Hat, right? So
Right, yeah.
what's your passion, and what are you working on?
So I work for Red Hat, and I am part of a team that does proof of concepts on Red Hat products, mainly the middleware products. And I work on Red Hat's OpenShift product, which is our flagship platform as a service product.
Okay,
And of course, that's my passion too. Yeah.
that sounds great. Um, how long was the way that took you to OpenShift? I mean, cloud isn't that new topic, but most people I know that work in cloud have some kind of Java E middleware background. What about you?
Exactly the same with me as well. So I got introduced to OpenShift because I was interested in middleware, mainly Java EE. So I've been using JBoss EAP for quite some time, and I was trying to build a product of my own in my spare time, and I was looking, and this is about like 3 years back, I think. Yeah, at least 2.5 years back, where I was thinking of setting up, building my own product, and I was not willing to spend any money. I was just a lone worker, a lone developer, and I was looking for how do I host this if I want to build and then share with my friends, kind of thing, like as I'm going through this. So at that time, the popular thing that everyone was talking about was Google App Engine. That's what I initially looked at, and I was almost like thinking of going in the Google App Engine way, but JBoss wouldn't run there, right? JBoss EAP wouldn't run there. So I was doing some research on what else can I use where I can build a Java EE application, and it's going to be standards based. I'm going to do everything as per the book, kind of thing, with Java EE book, kind of thing. So when I was searching, I came across OpenShift, and luckily the OpenShift just got released at the same exact time, so it was made for me, kind of thing. So I end up I ended up being the one of those first users of OpenShift online, and I created an account for myself, got 3 simple free gears. That was actually more than enough for a starter like me to build an application. And my app was doing everything service oriented, RESTful, exposing everything as a service. And I was mainly building the backend part. Front end, I kept it for doing later, which worked pretty well for me. I started with the JBoss AS7 or 6.1, I think. I don't remember exactly what was there at that time, but I used not the EAP version, but the community version of JBoss at that time, and I started working with OpenShift. But I was so impressed with OpenShift by that time that I started doing more and more digging into OpenShift, and over a period of time, at that time I was working for HP, and over a period of time, I came across an opportunity with Red Hat, not really relevant to OpenShift or anything. I mean, not really had anything to do with what I was doing on my side with the OpenShift product as such. But as I was applying for the Red Hat's position, I interviewed for a couple of positions. One of them did not actually go through it. I think it's all for a reason. Like you are made, God makes you do certain things in certain way, I guess. So the first position, I didn't. We had the interviews, everything went fine, but it didn't go through. But I was selected for another position based on the first interview, and that position ended up being a SME for OpenShift. So OpenShift was destined for me, kind of.
Perfect. That
Yeah,
sounds great. Um, OpenShift, I mean, we all played around with it, and it's pretty easy and straightforward. You
right.
talked about doing proof of concepts.
Hmm.
That sounds pretty bleeding edge. I heard rumors about upcoming V3 version, which is just in the making.
Hmm.
Um, are you involved with that already?
So you're right. OpenShift V3 is bleeding edge. When it comes to proof of concepts, right? What I have been doing for the past little more than a year now is on the OpenShift 2.x version, where I would go to customer's place. Most of the enterprises are not used to something like a PaaS in their environments. So what we do is that same OpenShift online product that's been used by uh, where more than 2.5 million applications have been deployed so far, right? That same well-tested product is what we provide as OpenShift Enterprise for deploying as private PaaS in different enterprises, and we provide that as a product for the enterprises to use internally. So what I do is go and help our customers to set up OpenShift in their own data center. So I take a couple of hosts, which could be physical or virtual machines, and set up this OpenShift on the top of that as a PaaS, and then help the customers understand how to manage that product on one hand, and help the developers on how to use that product on another hand. So think of it as having your own OpenShift online within your own data center is what I do for customers. That's the kind of proof of concepts I do.
Oh,
That was the first part of the question, right?
yeah.
The second part of the question was the curiosity of V3. V3 is all the great stuff, yes, and the beta one of V3, the beta was released just over a week ago, more than a little over a week actually, maybe a little less than 2 weeks. And yes, I am in touch with. I've been playing around with V3. It's not. I would say it's not. It's raw. It's a beta one, so that's what you can expect. But it's pretty powerful. Um, the reason why we are all excited about V3 is the containers that run in V3 are all Docker based, and the world is excited about Docker, and we are all moving towards Docker, right? So it's going to be a great product, and I can already see that as I'm running with that product. I last week I just installed OpenShift V3, and I have been able to deploy some applications, Docker-based applications on V3. It's pretty exciting to see all that coming together, and it's so very simple to where all these technologies like Kubernetes, Docker, and Red Hat's RHEL 7, which is atomic host, all these things are coming together to provide the next version of platform as a service for this world. So yeah.
Okay, you got me excited. Is there anything that you could show us today?
Sure, yeah. What I can do is, as I said, I have set up OpenShift V3 on a. I did it. I actually set it up on an OpenStack environment, and um, initially I was thinking maybe I can even show you how to install OpenShift V3, but it will be too much for a small call like this. What I can do is I'll show you how we can create some Docker-based containers which create an application using Docker, let's say, outside of V3, nothing to do with OpenShift, right? That's what people who are on the leading edge in the market are doing today. They are already using Docker. They are creating some applications in Docker, right?
Yeah.
Now, what I'll show you is how do we create that, and then how do we take that and import into V3 and deploy it there, and show how it works on V3, right?
That sounds amazing. Yeah,
Right.
share it free. Let's go.
Sure. Yeah. Uh, Let me know when you can start seeing my screen.
Not working yet.
Not working yet?
Nope. Still see you.
How about now?
Yeah, looks better.
Yeah. All right. So let me give a quick intro of what 3 is doing for us, right? OpenShift V3. And there is a small assumption that um, people who are viewing this interview have some understanding of containers, container-based applications, and all that. Being a short interview, I'm not planning to get into what containers mean and all that.
No,
Right?
that's pretty safe.
So, so in case of OpenShift V3, right? V3 is going to be deployed on the top of RHEL, and RHEL 7 is coming with what we call RHEL Atomic, which can run containers. So, to put it in short, we think of them as these are not VMs. In the past, we used to, if you want to set up an application, you would ask for a bunch of VMs where on each VM you have to have your own operating system, and on the top of that you will deploy the middleware to run applications and then the application code, right?
Yep.
But in case of containers, all those extra layers are taken away. You will just have the host which is running RHEL. That host could be a physical machine, virtual machine, or whatever you want it to be. It's a RHEL box, right? And if you want to deploy on an application on the top of it, instead of spinning up VMs, what we are going to do is spin up containers. And OpenShift V3 will actually support those containers which are Docker based. And RHEL 7 supports Docker containers out of box. It's all built into RHEL 7, and that's RHEL Atomic. Now, when we install OpenShift on a RHEL 7 box, what we are going to get is Docker-based containers running applications, right? And orchestration is going to be handled by a technology called Kubernetes. Kubernetes is what Google has developed, and Red Hat has joined hands with Google, and we are both part of that project now. And what Kubernetes does is it does orchestrate the creation and management of those Docker containers. And so as an effect of the combination of these two, we'll get a PaaS which will support Kubernetes, and it'll be able to interact with Docker Hub. We will also set up a internal Docker registry where you can post all your applications. It can interact with XPaaS technologies in the future. There would be connections to the marketplace, etc. And then we would also have user experience. Now, this is the overall stack of how OpenShift V3 is going to look like. As I said, currently we are in beta 1, so all the things are not fully in place on where we want it to be, but this is how it's going to look like. I just wanted to introduce on how the high-level stack is going to look like, right? Let me show you some concepts that are introduced in OpenShift V3. These are a little different from how V2 was. So we need to understand this in order to get into our example. So is the screen looking okay, or do I need to increase it a little bit more?
You could actually increase it a little bit more.
Okay. How about now?
Yep, better.
Okay. So we talked about containers that will run the technologies, right? So for people who already use Docker, they know it much better, that you can take any technology and run it inside a container. So for example, you could be running MySQL as a database inside a Docker container, right?
Yeah.
In case of OpenShift V3, we have an additional concept called a pod. And what pod does, and pod is a Kubernetes concept. What pod does is it'll allow a container to it'll wrap around the container, so it'll allow one or more related containers to run together. It gives that set an IP address, and it can expose the ports that are required by the individual containers. So all the networking aspects that are not handled by Docker directly are provisioned by Kubernetes. That is part of OpenShift V3. So when you want to create an application, right, what ports needs to be exposed, you are going to tell through the configuration, and Kubernetes will handle that for you. So you are going to have a pod for in this example that you're seeing here. You may want MySQL database and the administration for that as running as two separate containers, and both of those containers are boxed inside a pod which gets an IP address, and these two are exposing their own ports, right?
Question: how many pods? No, how many containers can a pod hold?
How many containers can a pod hold?
Yeah.
I don't think there is any limit on that. It all depends on how many are related and how many you want to run as part of the pod. Typically, it's not going to be more than 2 or 3, because you can have multiple pods which we are going to come see in the next slide. But basically, pod is like grouping of related containers together.
Organizational
it's not
unit.
Right. It's organizational unit. It's not for scaling or anything.
Okay.
Right. So if in the right side, you will see that there would be different types of pods you would use to set up a set of related containers together. My example on the admin, MySQL on the admin UI, PHP may be running its own pod. ActiveMQ and its agent, you know this better, right? They might be running in its own pod kind of thing. And then when you think of the hosts, right? A host could be running, the hosts will actually be hosting the pods. The pods will be running on the top of the host. So think of this white box that I'm pointing to as the RHEL 7 box, right? It could be a physical or virtual machine, anything, it doesn't matter. And the pods are running on the top of this RHEL 7, right? And some of them are running on completely unrelated pods, maybe mixed up together onto one base box. So the processes are independent, they are secured, and they are sharing the physical infrastructure, right? Now let's look at the other figure where we are talking about multiple pods, right? So for your application, you may want more than one instance of an application running. In such a case, you would have multiple pods, and all those pods are grouped together by using what we call a service. And I'm going to show you the configuration of a pod, service, and things like that in the example that we are going to look at, right? So let's say you have a label web for a service. Any pod that has a label web they are all pulled together, and the service will group them together as one unit. So from then on, any client requests that come in for this particular application will be distributed across all these pods, right? Any questions at this point?
No, makes sense so far.
Okay. Now let's come to our example. So the example that I'm going to show you is a PHP application, right? Interacting with a MySQL database. And in order to do that, what I am going to do is run MySQL in its own pod, right? And run PHP application in its own pod. You are running database as a separate pod, application as a separate pod, and we are going to connect both of them together and run both the pods on the top of OpenShift V3. All right. And I'll explain this figure in a little more detail. And as I'm explaining this figure, I'll also show you how these things are configured, right? So we are going to create a pod in which we are going to host a MySQL container, right? So let's say we go to GitHub. Let me trying to find the browser. Okay. Right. Sorry. Sorry. I meant to say Docker, not GitHub. Let's go to Docker, right? And if you browse here for MySQL, there is a image for MySQL that is available in Docker, right? So this is what, and it doesn't belong to any specific repository. It is a default Docker image provided by Docker guys. So we are going to use the same one. So right now, what I'm showing you is the OpenShift V3 installation. I'm logged onto that box where V3 is installed, right? And just to show you what is running here, is a section to that box. Network unreachable. Should we pause this for a moment?
No, we actually can't. So we can redo everything you would like to do. So if you can make sure it's not working, then we just find another slot.
It was all working just before I started the interview. So let me. Let me reboot this instance to see if it can.
That's already the V3 console, right?
This is actually the OpenStack, yes.
Ah.
And
yeah, I have to admit there's a lot of networking and infrastructure in all those kind of PaaS-y, cloudy things, and the middleware guy has to learn a lot.
so what happens is this OpenStack environment is it's a development kind of environment. It's not being it's not a production environment, so there is no support available for the environment that I'm using.
Mm-hmm.
So people are doing all kinds of funky things as we are working on it. So some people may go and change the network connectivity behind the scenes while I'm using it for something else. So yeah, okay, that's good.
Backup, obviously.
Reboot helped us. Yeah.
Okay.
So let me just quickly check whether everything is running okay or not. And, all right. So the registry container is, so what you're seeing here is when I install OpenShift, what all end up running there. So everything that gets installed with OpenShift runs as Docker containers, so or pods. So there is a registry container running inside its own pod. there is a HA proxy that is router that is running inside its own pod. So those are the two things that are running right now. And so make sure that the services are up and running. Master is inactive. Okay. Yeah, node. These are the things that get installed when you set up OpenShift. It hardly takes 20 minutes to set up OpenShift itself. So status of master again. Master is active and running. That's good. And all right. So let me show you a JSON file. And this is what we are going to use to create the MySQL pod that I was talking about. And this provides the configuration for the MySQL pod. So I'll take you to the easier parts first so that it's easy to understand. The Docker container that we were thinking of pulling from the Docker Docker.io, right?
Mm-hmm.
Docker Hub. We were referring to the image with name MySQL, right? That's given here. So all I'm saying is, I want to create a container. The name of my container is going to be MySQL container, right? And I'm going to use MySQL image from Docker.
This
and
is Kubernetes configuration file, right?
This is the configuration file. So right now, with beta 1, we are passing this configuration information using a JSON as input. But in the future, I think that just like in OpenShift 2.x, we are going to have a command line way of passing this information as well. But I am not sure of all those things yet. As of now, what we have is we create this JSON file and provide this configuration information. So all we are going to create this container, right? And at the time of container creation, we are going to set some environment variables inside the container creation process. We are going to have some environment variables for MySQL user, MySQL password, root password. A root user will be created, and it will also end up adding a database with the name sample, right? And what this container will do is it will expose the MySQL port 3306, and that's what we are configuring here, right? And then that's the configuration for the container, and it ends up creating a pod with the name MySQL pod, right? And that pod will contain this container which runs MySQL. At the same time, the pod has a label with the name MySQL-label, right?
Okay.
Now, if you go down, there is also another concept called service. If you remember the presentation, we had a service that gets all the pods together which have the same label. So this particular service with the name with ID MySQL service is going to look for all the pods with the label MySQL label, and it will group them together. And even this service is going to listen to this 3306 port from the pod, and it will expose a port 3306 from itself. So now coming back to this figure, right? I'm showing this part of the configuration where we have a MySQL pod, which is a component. Inside that pod, we are creating a container that is exposing a 3306 port, right? This is an exposed interface. And then there is a MySQL service that is again exposing a 3306 port. Now, on the left side, this is the actual application, the PHP application that's going to consume this service exposed by MySQL service, right? So this PHP application is going to run its own pod. We are going to have the PHP application source code in this pod, as well as the PHP itself. And I'm going to show that in a moment. And I'm calling this application DB test. And this guy is going to connect to the database service exposed by MySQL service. And this particular DB test pod would use an external route with the name dbtest.demo v3.oscloud.com, and we can access that through the browser, right? And this guy will have its own configuration, dbtest.json, and I'll show you how that looks like. So service is actually something, the service that you're seeing here in green is actually something that is not exposed outside the network. It is for communication between the containers running within OpenShift. When you want to expose something outside, you're going to use something called a route. And so when you look at dbtest JSON, which is the applications JSON, you will have the pod for dbtest, right? And the pod will again have a container for dbtest, a dbtest container. And this time we are going to use an image that I'm yet to create in my own repository at dbtest, and I'm also setting the same parameters so that I can access the database from my application code, right? The environment variables that I need to access the database from the application code.
Yeah, makes sense.
And the ports that are exposed by this container are port 80. So this DB test pod is going to expose port 80. And the DB test pod is just for the sake of networking again, right? Having all the related pods coming together, we would need a service, and that service would look for the label DB test label, right? If multiple containers are running, it will group them together. And the DB test route is going to be configured to point to this DB test service. So DB test, it will use based on the grouping that the service does, it takes all the spots and groups together in the router. And this is the name that the application will get, right? So with this single configuration, we are actually providing the application a name. We are going to spin up a container, and we are going to run that container. Now, having said that, let me get back to my local machine. What I'm going to do now, this is my local box, and I'm going to create that container that I'm talking about on Docker. So if you look at the source here, there is a dbtest.php, okay, and I'll show you what is there in that. This is a simple PHP file. It is reading the host name, the port ID from its environment, get-env, right? It is using the root as the database user. It is getting the root password that we had set in the environment variables. It is getting the database name, making a connection to the database from the application, and then after that, it's going to list all the users and display them. That's it. Very simple script. Now, there is also an index.php file which has just some dummy welcome text. That's it. Now, I'll also show you the Docker file using which I'm going to build this container. So I'm taking the PHP Docker image from one of the repositories. This Tutum Docker image worked the best for me. I just picked it up from there. And all I'm doing is I'm copying the source to var.www.html folder in this image. And then I'm going to build a Docker image and push it. So now let me the name I'm giving for my Docker image, and I'm building it from here. Okay, sorry. Actually, I need to check whether the Docker is running. Okay. Let me start the Docker image. Give me 1 second. All right. So now the image is built. You can see that this image is there. Now I'm going to push this image. So I'm building a Docker image. I have built a Docker image on my local box, and I'm pushing it to Docker Hub. Yeah, here it is. All right. Now let's get back to our OpenShift box. And in order to, I'm going to spin up the pod that runs MySQL first. So what I'm going to do first is create my own project. So if I do OSC get pods right now, it's going to show all these OpenShift related pods here. And I want to create my own namespace first so that I'm not mixing up my pods with OpenShift related pods. So I'm creating a namespace called user, and I'm going to start using that namespace. Now if I do OSC get pods, it won't show any pods because there are no pods running in this namespace. Now using this Docker, this JSON file, I'm going to run the MySQL container. So OSC create -f test. So it spins up, as you can see, it spins up a MySQL pod and a MySQL service. So if I do OSC get pods now, you'll see that MySQL pod is running. And if I do OSC get services now, it should show MySQL service. And this MySQL service is running on so-and-so IP address, and it is exposing port 3306.
That
Right?
was damn quick, wasn't it?
Right. It was pretty quick. So all it did is it just pulled the MySQL image and then it spun it up. Actually, I pulled the MySQL image upfront, like the Docker image itself was pulled upfront. So that's the reason why it was so very quick. But in case it has to pull the image from internet, like how we are going to do for the DB test thing, because we just created the image, it's going to take a little while. So we are going to see that process happening. So right now we have this service running. Now let's before we start using the application, right? Let's see whether we can actually connect to this database and start using it, right? So what I'm going to do is spin up another Docker container, and that by using this -- remove flag, if I get out of this, this container will get destroyed. And I'm spinning. I'm just starting a bash script. Now, what I'll do is I'll try to connect to this MySQL database from this container. So host IP is 172.30.17.238, and port is 3306. User is root. Password is okay, super secret. That's it. We are in a different container altogether. We spun up a new Docker container, and from this Docker container, by using this MySQL client command, we have connected to this service on this port. And using the username and password we gave, we actually logged into the other Docker container which is running MySQL service. So in this figure, we actually logged into this from outside. Now, if I'd say show databases,
You can't actually see me smiling, but you're logged in from your local machine on a remote OSE instance, spun up a Docker image with a MySQL client, and connected to the Docker pod running MySQL, correct?
right, from another Docker image. So,
Ay, Jesus.
right.
Okay.
Now, if you see, the sample database that we gave as a parameter is already created. So I'm going to use this sample database, right? Now, let's add a table to this, right? We will need the table anyway for our use within the code. So we'll add this table, a users table, and then we will insert a record there. Select star from users. So my record is there, and I am exiting from this. Now I am still inside the Docker container that I have spun up. If I exit from here, the Docker container will be removed. The reason is, look at this command. I use this -- remove option, right? Which means this MySQL based Docker container that I just spun up will be removed immediately after it is used.
That's a handy trick.
Yeah. Now what we'll do is spin up another pod. Now we are done with the right side. We tested it, right? Oops. We tested this MySQL service connecting to MySQL pod from outside. Now we are going to use this dbtest.json to create the dbtest pod, dbtest service, and dbtest route. So again, the command is, so if you look at get pods right now, oops, you'll see only MySQL pod, right? If you see get services, you will see only MySQL services, and if you see if there are any routes that are already running, there is nothing. Now we will do OSC create -f dbtest.json, and this should create all three. So it has created a dbtest pod, it has created a dbtest service, and it has created a route. So now if I do OSC get pods, it has created a dbtest pod, but you can see that the status is still pending. The reason is it is downloading this Veer hyphen dbtest image from Docker Hub. Once it downloads and starts, the pod is spun up, the container is there, but it is still downloading this guy. So once this is done, this status should change to the running status. Okay. So see get services. So it should show you the dbtest service, right? And it is looking for all dbtest labels. And if I look at routes, to show this route. This is the dbtest.debov3.osccloud.com. If I try to access this, let's see what happens, because it's not running yet, right? It's a service not available. Let's wait for it to get to the running state. It depends on the internet speed on how long it takes to download that image.
In this case, it actually includes Tomcat, which is pre-installed with PHP.
Yes.
Okay. Yeah. Might take a while.
Yeah. Right.
And one of the key parts of OSE V3 is actually that you'll also be able, as a customer, to use your own, how should I call that, Docker hub, private Docker hub?
Right. So if you, when I set up OpenShift V3, right, I'm not only able to connect to the Docker hub, but I can also set up my own registry on this, and I already installed my own registry on this V3 instance.
Okay.
So yeah, as a customer, you can have your own private registry where you put all your images there and not shared with others. That's right. It's running. Okay. Now let's see. Welcome. Try dbtest extension. dbtest HP. Connected to the database, and it pulled my record and showed it.
Okay. I would say that worked pretty good.
Yeah. For a beta, this is an example of create your own Docker images right outside, and then those may be already there. You may be using them for your Docker-based applications for some time. For those who are already using Docker, it doesn't take much time to actually take it and run it within OpenShift. It's as simple as this, right?
Yeah, I have a question. I mean, you've been talking about services that pick pods by labels.
Mm-hmm.
Is it safe to assume that every request against those services is more or less stateless? So how does the service pick the pods? Is there any stateful connection?
Generally, uh, the I have not dug deep into that aspect yet, but what I understand is like um, for the current day applications, when you are trying to run scale applications across multiple containers,
Yeah.
you would generally follow the stateless principles anyway, right?
Okay.
If you are scaling out horizontally, then you would follow the stateless principles anyway. But are we implementing sticky sessions kind of stuff or not? I don't know that answer to that question yet. I need to check with the team.
Okay, fair enough. Thanks a lot. That was quite impressive. I didn't expect it that it might take that long, but at the end of the day, it was a full-blown round trip. So thanks for that. And I'm really, really, really keen on seeing some more Java EE stuff running on that. So the next time, I'll definitely poke you about trying to get Wildfly stuff running on OSE. Betas should come out comparably quickly, and everybody can follow the OpenShift development in the origin tree anyway. It's all free and available on GitHub. That's right. So, yeah, whenever somebody wants to get his hands dirty with that, as of today, it might be a good idea to check out the GitHub Shift Origin project. Um, Thanks for your time. If we could make it work, I'll drop by your place in Atlanta next week for that Nexus. So thanks a lot and hope to talk to you soon.
Perfect. Thanks a lot for the opportunity, and it is a good one. Yeah, thank you. Sorry about the delays because I didn't realize that some of the services were not up and running before. I should have done some
Fair enough.
started some of the services upfront. Yeah,
It's a live
thank you.
demo. Okay,
Yeah,
goodbye.